Hello and welcome to the latest episode of Java in the Cloud. Today I've got Matej here, who works at Infinum. It's a consultancy helping people develop modern applications. Matej's got a lot of interesting experience, and today we're going to talk a little bit about D-SQL and his work in open source. Matej, do you want to give us a quick introduction?
Hey, Mark, thanks for having me before everything. So I'm working as a lead Java engineer at Infinum and helping our clients scale and all sorts of other things. And beside that, in free time, I am one of the maintainers behind Spring Cloud AWS, which does all integrations with popular AWS services such as SQS, S3 Bucket, SQL Manager, and many more. And to use it in the same way as you would consume other services with Spring. So it's idiomic. It's really easy to switch between, for example, Kafka and SQS and all other sort of the things. And
Yeah, I'm a big fan of the Secrets Manager integration. I created another YouTube video about it, how it just kind of seamlessly connects to Secrets Manager, grabs the details that you need, and then it does all of the Spring magic to kind of connect to the database easily. So behind the scenes, you're using Secrets Manager, but really from a programmer's point of view, it's very, very similar to just using environment variables or something else.
yeah, we really try to hard to make it so simple to use that you just mention one line and it automatically loads. Then if you want to reload periodically, it does all of it for you. It reloads the beans as well. We really put effort into making it most user-friendly as possible.
Yeah, absolutely. And I think that's something that, people really appreciate. You do see people using it. It's got a lot of activity. You're really trying to, keep pace with all of the releases with AWS. So, if people were interested in helping out, what's the best way that they can kind of help out with the project?
Well, we have some open issues that is for community grabbing. So if you want, we encourage it. Feel free just to ask if you can take the issue. Well, since this is a community project, sometimes it will take time for response because we all have our work life and then we have personal lives, but we try to respond as soon as possible as we see the messages, right? But if you want to contribute or even are interested in how something works behind the scenes, well, you can always go to discussions, make a question, or just pick the issue and take it.
Awesome. Okay, so that's a little bit about Spring Cloud AWS. Fantastic. And thank you very much for doing all the work to maintain it. But today we're talking a little bit about D-SQL. So do you want to give us a rundown about what D-SQL is?
Well, for me, it was really interesting once they introduced D-SQL because I think it's a real game changer in database universe. It basically rethinks the whole databases from scratch. If we go a little bit in past, why we use databases like back in 80s and 70s, it's to reduce the space on disk mostly. Disk prices were really expensive and we wanted to fit as much in smallest possible space, right? And today we have these big data centers, we are growing, we have better networks and so on. I mean, latency is still the issue because we cannot change the physics, but we are now moving into distributed space with all the trends. Everyone has access to the internet, means the more requests and so on. So the SQL is basic distributed SQL database, which has a storage engine fully separated from query processor and transaction layer, which is not something you usually see, for example, in Postgres or other databases where you have everything on single machine. Here it's distributed across many machines, and to be honest, it's just totally different database from anything I have seen before.
Yeah, so this is the first, I think, truly serverless database that AWS has, relational database that AWS has released. We've always had things like Aurora and Aurora serverless, but I feel like anything that's called serverless probably isn't entirely serverless. It doesn't scale to zero. Whereas D-SQL is truly serverless in the way that S3, SQS, Lambda, DynamoDB is serverless. So you're only paying for use. It scales automatically up and down. There's no infrastructure, no maintenance windows for the user. You just connect to the endpoint and start using it.
Yeah, it's actually really interesting if you mention lambdas because they share a lot of similarities. They both use micro VMs. They use router to route your request to the specific micro VM, then start micro VM for you. Same is with storage engine. It's allocated for you. You don't have anything to do with it. It just starts and does computing and storage for you, which is insane if you think about it.
Yeah. So what sort of use cases are they suggesting that people use D-SQL for? Where's the sweet spot?
For me, firstly, it would probably be for sure for serverless and lambdas because of the connection and having connection in lambdas and keeping them live. It's most expensive thing to have in when you're running the query probably. And with D-SQL, it's really easily because you don't have any more connection limit on the database because you don't have a single instance. You can scale horizontally, which is totally different than you have in RDS or Aurora. You could use, for example, AWS proxy, but then you have overhead of having a proxy managed connections and so on. So here we just seamlessly connected directly to query processor and database itself.
Yeah, there was always this strange kind of balancing act between, when to use RDS proxy and when to go to the database directly. And it wasn't just a trivial decision point where you can just say, just use RDS proxy or never use it. It was always the decision based on, what the use case was, how active the database connections and queries were as part of the Lambda function. But now there's another decision kind of taken off the developer's shoulders because with D-SQL you don't need a proxy and you wouldn't ever use a proxy.
Yeah, and especially I think this is important for startups and smaller companies because it allows you not to have high bills and you can have really fast development cycles because you don't have any infrastructure, you don't have to carry it, you don't really need to manage it, and you don't need actual expertise in, for example, in Kubernetes is, you would have, or database. You would usually had database admins that were upkeeping the database for you. Even with RDS, you need to little bit know certain things, but here everything is taken out from you. You can scale later. So it's really building that AWS serverless ideology where it will allow users just to quickly iterate and then scale later if they need to.
Yeah, and that was always an interesting issue with serverless architectures using a relational database is that it was very easy to set up ephemeral environments where you would have API gateway, Lambda functions, all completely ephemeral. And then, you'd have an RDS database that, if you wanted it similar to production or, anywhere near reasonable in size, then you would always have that incurring cost on a bill. And, maybe an enterprise level it's not a particularly big deal, but, when I look back at when I was developing software before I joined AWS, we had a development environment for every developer on the team. So we had 10 development environments. So if you had 10 RDS databases, obviously with very, very little usage, you're still paying for all this infrastructure. And that's kind of the cost of doing business. Whereas I see something like D-SQL, and it just seems like a fantastic solution to that, to relational database, but also it really fits in the serverless mindset and with the ephemeral environments.
Yeah, you're not longer pushed to DynamoDB because DynamoDB is great, but it has its own use cases. But now you are allowed actually to use SQL and pay as little. So maybe you're building some of your own projects, or you have maybe project that is only working on day while it's night. It does not have many requests, but you still need to serve them. Well, Lambdas and this D-SQL are now the best solution you can have, probably.
Yeah, and that's something that really connected with me when I was watching some of Mark Brooker's talks about D-SQL. Was that he was talking about this is something that can scale to millions of requests a second, but also deal with workloads that are tens of requests a day, and that variability of scaling is, I think, incredible as a solution. And again, helps people to delay, architectural decisions. You can probably get a long way now with API Gateway, Lambda, and
Yes.
D-SQL as a 3-tier stack. That's gonna cover, trivially 10,000 requests a second. I imagine this is this is amazing.
Yeah, and then also if you think about it, if you need some kind of back processing, later, then you have SNS, SQS, or Event Bridge. So basically, you can have whole stack for being event driven and also to serve single request, per time. So it's growing into something where basically you will just have serverless in some cases and pay for requests only, compute
Yeah,
time.
but I guess the caveat to that, just like everything, is that there's trade-offs, and in particular, D-SQL isn't just a relational database for every use case. This isn't a database for analytic workloads. It's not a data warehouse. Separate services for those. But maybe let's talk about the programming model and how people would use T-SQL. Okay, so this is a really useful repository for anybody who's interested in trying T-SQL out. This is a repository that AWS has made, and it has an example pet clinic application. So the interesting code to have a look at here is some of the configuration. Yeah, let's talk about how this is configured. Do you want to have a quick walk through this code?
Yeah, sure. So firstly, if you go on the top of your class, you'll first note its configuration class, meaning it will be creating certain kind of beans, data source beans, as you can expect from the name. Here we'll have enable scheduling. I think we can talk a little bit later about this, but it's really important, and it's one of the ways that it's actually, you have to use it in order to work with the data source. Here we have certain values such as region, we have action, max lifetime username, which are configurable. So you can configure on your own, just specify them in your application properties. And now we come to the most interesting part, which is data source bean itself. You can see it's marked as primary, so Spring takes it when you're running your maybe JPA, Spring Data, JDBC, it will be automatically used for you. And here we are creating Hikari data source, which basically has its own connection pools. It's not closing and opening connections for you, so you don't have to worry about it. And here we are setting certain variables such as max lifetime of the connection and so on. Now, if you go to generate token, I think we can maybe go directly to it and talk about it. It's interesting because D-SQL is using token for authentication. It does not use username and password as you have, for example, in Postgres or in RDS, right? RDS and Aurora. You also cannot use IAM authentication that you could with RDS, but you have to generate this token. Here, you're just using the SQL utilities, which is AWS SDK class, to generate the token. You can mention expiration date, so how long it will be valid. Here it's 900 seconds by default. And you generate the token and you set it on the data source. So Hikari will use it in connection pools and so on. Just a note, when you're building DSQL utilities, you always need to have correct time credentials in that you can really generate the token. You need to target the correct region where this SQL will be resided at, and so on.
Yeah, and this is probably slightly different to where people have typically kind of interacted with the database, but this is still a Postgres dialect. So people who have written their applications against Postgres and have SQL written for Postgres, this is probably going to be completely seamless for migration.
Yeah. Even though behind the scenes, everything is totally different. You have query processor, which is not doing aggregation anymore. Everything is delegated to storage engine. So there is no hops behind query processor and storage engine, which you had in RDS, for example, or Aurora, where you had those big caches. Here, everything is deloaded to storage engine. It does all the work and returns the result.
So maybe this is a cheeky request live on air, but this feels like work that each developer would have to do at this point. I could imagine this being, something that Spring Cloud AWS could integrate into the project to save people having to work out how to do this kind of custom authentication and custom security workflow. What do you think?
Yes, I think it should be a really great feature, especially because token has to be generated every so and then.
Yeah.
And you have to specify it against the data source. So yeah, I think we can use it with our credentials provider because we support many credentials, STS, default ones, and so on. So it could really integrate well with data D-SQL integration.
Well, there you go. If you're watching this and you want to contribute to an open source project, this might be a good place to start. And I think it would be a really helpful thing because I can imagine lots of people would look at some of the samples that have been produced by AWS and, maybe they're writing a Lambda function and they're not sure if the token has expired or not, and they will just generate the token before every request. So I think there's a risk of, making far too many network calls, and, there's probably all sorts of improvements that can be made to help people work out how long a token has been around for and when a suitable time for it to be refreshed is.
Yeah. Also VPC, VPC costs can be high if you don't think about them. So yeah. Also, interesting point here is if you notice there is only one data source, there is no read replicas or write replicas, everything is one data source. And this is because of the SQL naturality being active, meaning you just connect to the query processor and they do load balancing and all of this for you. So there is no more read replicas. You only have one data source. You don't have to generate in Spring Boot. You usually had to generate multiple data sources, then check if it's a read transaction that it goes to read replica. You have to check transactional then and so on. Here it's much more simplified. It's offloaded to the on AWS side and you do.
So again, they've taken steps to simplify the programming model, making sure that that is handled from the infrastructure side and reducing the complexity of the developer code, which is, I think, super cool. I think the other really mind-boggling feature of this database is the way that it handles multi-region support, and it's very rare for AWS to have services that truly work in multiple regions. This one is pretty unique. Do you want to talk about some of the innovation that AWS has added to enable this?
Yeah, for me, to be honest, biggest game changer is probably time service from AWS and atomic lock. I think it does not only, well, in this case, we are now being able to use time as a reliable source. If you remember, everyone before, when the papers were written, wanted to use time but couldn't because clocks were not really reliable. So we were using transaction IDs and certain stuff to check if really we can commit to the transaction or to read actually the data and that it cannot change, that it's right isolated and so on in the time. Now, if we can have microsecond accuracy as AWS has, especially across the region, we can then really believe the time. And maybe if we are in EU West, talk to Amazon in US East one, give them the time that we are wanting to read the database from that point in time, and we will actually get that data, because microseconds difference is really, really low, and we can live with that in most cases.
Yeah, I feel like this was such a fundamental change in distributed systems. And, I was talking to some of my colleagues at reInvent at the time, and, we all believed that this was probably the biggest, most important release. I know it's very boring from a user's point of view, but having accurate time has enabled, multi-region support in a relational database, but also multi-regional support in DynamoDB for atomic writes and reads. I mean, absolutely fantastic. And I think now that this capability is available, you'll see a cascade of further releases where more services can kind of look at how this has been created and maybe adapt their own services. So, could you imagine, a multi-region SQS queue or, something like that? Wouldn't that be amazing with the same sort of consistency behavior? I mean, it really makes me think about how I could have an application deployed to 2 different regions, and I could use this database as an item potency store. So I could send data and requests to 2 regions in an active design, and then I could only have one of them being actioned. And I just think that is fantastic, because if I tried to try to make that architecture before this database, I have no idea how I would keep it consistent and only once processing. I think it would be close to impossible, or definitely have a lot of manual steps on a failure.
Yeah, of course. It will be eventual consistent. You will need to have used something like Spanner does with plus minus time and hope for that it got there in the
Yeah.
this. It's really, I think, ahead of time, but it also allows you to build services in more resilient and quality life, because you can now drop requests. Maybe if you notice that you won't have time to process them, you can just say, hey, listen, I will just drop them. So fail fast and all those sort of things become available, because you can ingest in your Fargate or your Kubernetes this time service and have really microsecond time across all of your services. So this is really, really great.
Yeah, fantastic. The other really interesting code sample in the AWS example is this transaction retry aspect. Do you want to give us a bit of a walkthrough of this code?
Yeah, sure. As you can notice first, transaction retry aspect is annotated with aspect and component, meaning that it is weaving around the method you're going to be using. For example, if you are saving to database, it will be catching and it will be triggered, in our case, if you can see, around transactional annotation. And it will use platform transaction manager to actually commit or roll back the transaction. And reason here is because in D-SQL, you don't have locks, because everything is distributed, everything is separated in many services. Only later in the process, adjudicators are deciding will your transaction be committed or rejected. And here you can then catch these exceptions and do the retry, because now you have to do it manually on your own. So here you are catching the exception, and basically you're if you can go down, you are incrementing the retry count, and if retry count is above the max retries, then you fail it. But if it's not, then you continue and start with the retry process manually.
Yeah, so I guess the way I try and think of this is that you could have an update to account, and if you have 2 updates at exactly the same time, one of them will read the value at one time, commit at another time and be successful. And then the second transaction, there will be a exception thrown because the read is before the transaction committed. I think I've got that right. So it's sent back to the client to say, we tried optimistically, but there's been a failure. But in that case, because we're updating a counter, it doesn't really matter. We just retry.
Also here, it will be probably perfect place for, how something has changed. Should I maybe try this, to try this transaction again, or certain values change? I need to give my client back on front end. Hey, please decide what are you going to do now. Here are refreshed values. Someone updated it. Please, decide.
But we're talking about such highly contested data for these things to happen, right? We're talking about things that are happening within milliseconds to the same, parts of data. Unless you have a highly contested part of your database, I think most people are never going to be able to see this, right?
Yeah, you really need to have hotkey or hot char, but this is really, really, usually it's not the problem.
Yeah, cool.
There is one more thing actually that's interesting. If you have read or have seen the architecture of adjudicators, and so I pulled here Mark Brooker's blog, which is, by the way, best source of information beside documentation for SQL. And as you can see this picture, we have AZ endpoint, and it talks directly to query processor. You can imagine it, there is one more router behind the scenes, which you don't see, similar to Lambda architecture, and it chooses one of these query processors to talk to. Query processor, though, when you, for example, make just simple select, have high level communication towards storage, and then it goes directly to the storage engine. And storage engine, based on the time you have chosen, well, query processor will say, this is the time I'm making the request. Please give me the date time in what's the data in this time frame. And it will say that, I don't know, 1025, this is the data that is located on the storage or was located, depending. And then it gives this data back to query processor. So if you have some kind of aggregation, it will be happening at the storage level. It won't go directly to the query. It won't go back to query processor, then query processor, because it used indexed. I now need to go to the location on disk and so on. Complex stuff. It happens on storage engine directly. But here, I mentioned adjudicators before. They are basically deciding if commit should happen or not. And then if they decide that commit happens, then they are writing it to this journal. So nothing is written to storage engine directly, but storage engines will pull from the journal and then write it to their disk. And as you can see, in that exact time that it was committed to the journal, commit will be returned to the client as well in parallel, which again improves the throughput and so on. But interesting now to think of, if you have this journal, you can use it for different patterns as well. What I'm expecting in future one day to see is that in this journal, you can also maybe message to Kinesis directly or to SQS and have outbox pattern out of the box with one click, and you just pay for it. And I think we are going to see with this time, atomic clocks, we're going to see a shift of services and whole other architectures that we have not seen before.
Yeah, absolutely. I think that's a really astute point, and it would make it very easy to do. That's our sort of outbox button. What has changed? What is the specific changes that have been made in each and every transaction? That'd be really interesting. And actually, on the flip side, D-SQL is something that my company is looking at as a way of allowing users more control over data that's in DynamoDB. So at the moment, we're looking at DynamoDB, taking a stream of all the changes in DynamoDB and then turning that into a relational database that people can query with ad hoc queries. So that's obviously something that's reasonably hard to do with DynamoDB, and you have to think about all the different access patterns. And one of the really strong strengths of a relational database is just having, lots and lots of variability around how you query it. So yeah, we're taking the database changes from DynamoDB, streaming them into a Lambda, and then putting the data into D-SQL into a form that can be queried. So I guess it's going to give you, a lot more options around, serverless architectures. Really being able to kind of use relational patterns again without incurring high costs for spiky workloads. Very interesting.
Now that you have mentioned the lambdas, I also think that we are going to see a lot more of ETL happening, because this use case is you in DynamoDB, you really need to know your query pattern beforehand if you want to build correct model. Well, not correct, but efficient model. And you're then transforming this to SQL database that you can use for complex filtering, for example, and so on. And you are then spending your Lambda concurrency on ETLs, right? So with this serverless stack, it would be great that you can, make your own Lambdas and not waste concurrency of them because they need to serve the request, and just have it differently for ETLs. And again, we are seeing the serverless stack just being enhanced more, that you can now support basically your maybe whole application with just Lambdas.
Yeah. Very, very cool. Okay. Yeah. Thank you very much for joining us, Matej. It's been really interesting, and looking forward to seeing, what comes out of the next reInvent. This service is obviously generally available now. It's GA. It'll be really interesting to see what happens at the next reInvent and how people are using this, and another opportunity to kind of get some more interesting ideas. But yeah, I think we need to have a little chat with Mark Brooker about your journal idea. That sounds really interesting.
That would be really interested, and I would really enjoy that.
Okay. Thanks for joining us, Matej, and bye for now.
Thank you for having me, Mark. Have a nice day.